In this video, we're going to talk about the change of base theorem. Now, if a logarithm has either base 10 or base e, then we can use a calculator to find it because our calculator has a natural log button, right, a log base e button, and also a log base 10 button. So, for example, in my calculator, I typed in natural log of 137, and I got some crazy decimals, 4.91998. 0.9, and so on. It's just this decimal that keeps going on and on and on. And also log of 137. We could use our calculator to find this. Now notice the base here is 10. Okay, if we see the word log written without a base, it's assumed to be 10. And actually, before we plug this into our calculator, let's try to guess what the answer would be. Now notice the question is really 10 to the what power is equal to 137. Now 10 to the 1 is not big enough. 10 to the 1 is just 10. 10 squared is still only 100, but 10 cubed would be too big. It would be 1,000. So I expect our answer maybe to be a little bit bigger than 2. Okay, 10 to the something a little bit bigger than 2, that would equal 137. And in fact, I did plug this into my calculator and I got 2.13672 ... Again, it's some crazy decimal that keeps going on and on. But if you took 10 to that power, it would equal 137. Okay, but now the question is, how could we find log base 5 of 137? Okay, we don't have a log base 5 button on our calculator like we do the natural log and a log base 10 button. So even if we have a calculator, how do we figure out what log base 5 of 137 is? Okay, and we're going to use what's called the change of base formula. Okay, that's the answer, is to use the change of base formula. And this says that for any positive numbers a and x, and we don't want a to be 1, log base a of x is equal to natural log of x over natural log of a. So we've converted a log base a into two natural logarithms, and our calculator has the natural logarithm button. Okay, so let's use this change of base theorem to find log base 5 of 137. And again, before we actually plug it in, let's take a guess and think, what would this be approximately? Okay, now 5 cubed would be 125. That's not quite big enough, but 5 to the 4th power would be way too big. That'd be 625. So I'm guessing the answer would be a little bit bigger than 3. Now, according to the change of base formula, the a here would be the 5, and the x would be 137. So we can rewrite this as natural log of 137 over natural log of 5. And if we plug this into our calculator, natural log of 137, it's 4.9199809, etc. And if we plug in natural log of 5, we get 1.609437912. Again, some crazy decimal. But then when you divide these out, what you get is 3.056956, etc. And this is the answer. Okay, 5 to that power would equal 137. Okay, now a lot of times this intermediate step here, you don't have to figure out what ln of 137 is and ln of 5 separately. You could just do it in one step on your calculator. Do ln of 137 over ln of 5, and it'll give you this final answer. Okay, now part B, log base 2 of 100 equals what? Okay, well, 2 to the 6th power, I think, is 64. Okay, that's not quite big enough, but 2 to the 7th power would be 128. That's too big. So I expect our answer to be somewhere between 6 and 7. And in fact, we can type into our calculator natural log of 100 over natural log of 2. And what I got when I did that was 6.643856, etc. Okay, so a number that's like we thought is between 6 and 7. Okay, now the final question is, where does the change of base formula come from? Okay, why is it true? And I hate to just give you a formula and not really explain where it comes from. Well, in a future video, an optional video, I will give a proof of the change of base theorem.